Happy weekend, chemistry folks. Today's chemistry lesson is brought to you by Paula Abdul. Before she was a judge on American Idol, she was a pop star singing songs like Opposites Attract. And I thought that was very apropos for what we're talking about today, polyatomic ions and some more ionic bonds. So let's go ahead and take a look at the starter that we had on Thursday. Many of you were not there because of, I suspect, not feeling too well. And I empathize with that and can give you a little bit of a leg up on this week coming up by doing the starter that we had over. So your starter is going to be to answer these questions. What is a polyatomic ion? Give a few examples. What are the first two steps of drawing polyatomic ions, the Lewis structures? Number 3 asks to complete the first two steps for the Lewis structures, and 4 also asks to complete some steps for chlorate, which is a specific polyatomic ion. So I'm going to give you about a couple seconds to pause the tape now if you want to do these questions, and we're going to go over the answers very shortly. Alright, it looks like you're ready to go over these answers. What is a polyatomic ion? Give a few examples. Polyatomic ion is a group of bonded atoms that collectively carry a charge. So instead of just having one atom with extra electrons or extra positive charges from electrons, they are a group that are covalently bonded, and all together they have extra electrons than they should, or less electrons than they should as a group. Okay. Some examples could be chlorate, oxalate. We have some hydroxide ions that we can put in there as well. What are the first two steps of drawing a polyatomic ion? Well, those you are going to need to memorize, and the first two steps are going to be to find the formula using reference table E in your chemistry reference tables and determine the valence. And last but not least, we need to look at how to do the steps for chlorate. And I'm going to start you off by saying the first step is to find the structure. The structure is going to be, the formula is going to be ClO3 2-, and ClO3 2- is where we're going to go ahead, and that'll be our departure point for how we need to do this. So let's review the 6 steps again for drawing these Lewis structures. Step 1 is to refer to the chemical formula. So chlorate is given on this chemical reference table, called selected polyatomic ions. And it is down here. ClO3- is chlorate. The 3 is a subscript to let us know that there are 3 oxygens in here, 1 chlorine atom in this group, and all together they carry an extra negative charge. So there's 1 extra electron than there needs to be. Let's take that information to the next step. Step 2 asks us to look up each element on the periodic table for valence electrons. And if we look at the periodic table, we have 2 different types. This one is from your chemistry reference tables on the left for oxygen, and on the right is the one in your textbook. Both of them give the same information, that just come from different places. If you look at that second number in that simple electron configuration, 2-6, or here 2-6, that second shell, that last shell, that's our valence shell, and that's how we get our 6 valence for each oxygen atom. We also look at the same information for chlorine. Again, we're looking at that last number, that last shell, and that's how we get that there are 7 valence for each chlorine atom in this. Now that we know that, we can go ahead and start with step 3. We need to add in any negative charges or take away any electrons for positive charges. Once we have done one last thing, though, with this, and that is to multiply if we need to. So you see that 3 there is important. We have 3 oxygen atoms here. We know that each one has 6 valence. Well, 6 times 3 is the total valence for oxygen that we have available. The total valence for oxygen will be 18. For chlorine, it's a little easier because we don't have a subscript here. That lets us know that automatically it's 1. So 7 times 1 is 7 valence total. If you're having a hard time with this part, I advise you to look up on YouTube how to calculate valence electrons. Alright? The ion altogether, you might say, has 25 valence total, but you have to remember this charge here. This extra charge lets us know that we have an extra electron, and there's 1 extra. So now when we add all these numbers up, 18, 7, and 1, we are going to get, pause if you want to stop right here to see if you can figure it out. The answer is 26 valence electrons total. To help us out with counting, instead of counting a bigger number like 26, if we divide by 2, we know how many pairs of electrons that we need. So we have 13 electron pairs total that we need to place. We're going to use this information with our original formula to figure out how the structure should be written. So the very first step is to put the first atom in the center and others around it. So we're going to have our Cl and O, O, and O around. What we'd like to do as well in here is now figure out how we're going to place these electron pairs to satisfy the octet rule. I like to start with the most electronegative element because that's the one that's going to want the electrons the most. So that will, in this case, be chlorine. And to satisfy the octet rule, chlorine is going to need an extra. And so now I have just placed 2, 4, 6, 8 electrons around chlorine. It satisfies the octet rule for chlorine. I have all these oxygens, which are also pretty electronegative, but not as electronegative as chlorine around that. So I'm going to need to put some electrons around those as well. Since I use 1, 2, 3, 4 pairs, I still have 9 to place. So I'm going to start just by placing them equally around the oxygens here. So I have 3 that I've placed there, so I have 6 left to place. I have, once I put all 6 of those pairs down, I'm just going to check really quickly to see if I satisfy the octet rule for everything. This oxygen has 8 electrons available to it. Chlorine, we already said, has 8 electrons available to it. This oxygen has 8 available electrons. This oxygen has 8 available electrons. And just quick count to make sure that we haven't cheated here. We should have had 13 electron pairs. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 that we placed. So we have placed the correct number of electrons and satisfied the octet rule. Step number 6 is going to be to change all these lone pair bars to dots if you use the bars. If you would not like to change these or do this step in its full extent, you can just avoid using bars when you're doing lone pairs and only use bars when you're making these bonds if you'd like to kind of condense these steps a little bit. But if you like the bars, which I kind of do, you can continue to use them, but make sure that in your final answer you get rid of that. Let me show you what that looks like very quickly and easily. We're only going to get rid of the bars that are not bonds and add a bracket there. So I just replaced every lone pair bar with double dots to show that. And the reason that we do that is to make sure that anybody who is checking your chemistry regents will understand your notation, because it's not very common to use the bar. The last thing that we need to do after we've added our brackets to show this is to go ahead and represent the extra charge on this, and now we have the full Lewis structure for chlorate. Okay? Check your answers, pause if you need to, rewind if you need to, see what you need to do. I'm going to pause it here. Alright, we're back, and let's take a look at